field, which is B equals 0.5 teslas to the right in the x direction. The proton has a speed of 1 times 10 to the 7 meters per second in the direction shown. So we'll do part A first, where V is up at an angle. It's in the XZ plane. We want to find the force there. And then in part B, we've got V in the negative Y direction, and we'll find our force there. And we'll do A and B separately. We'll use two different methods to find it, just to make sure we have a good handle on both ways. So we know we're going to be finding magnetic force. We know magnetic force is QV cross B. In our problem, we have a proton, so right off the bat, we know that our charge Q is plus of the fundamental charge, 1.6 times 10 to the minus 19 coulombs. Okay, so we're good there. Part A, if we want to find the magnetic force, let's write down what B and V are. B is equal to 0.50 teslas in the x direction, I hat. V's got components here. It's got an x component, that's horizontal, and it's got a z component, that's vertical. So there's Vx, there's Vz. So our vector V is the x part in the x direction plus the z part in the z direction. The x part is going to be V times cosine 45. And the z part is going to be V times sine 45. Let's see. V is 1 times 10 to the 7. Cosine 45 is root 2 over 2. That's 0.707. So 0.707 times 10 to the 7 meters per second. Same thing here for V times sine 45. 1 times 10 to the 7 times root 2 over 2 is going to give us 0.707 times 10 to the 7. Okay, there's our velocity vector. So now let's use this in our equation for magnetic force. Let's find the magnetic force on the proton. FB equals, for Q, I'm going to fill in E. V cross B. Let's fill in what we have here. E, I won't write that one out just yet because it's a pain to write out. V 0.707 times 10 to the 7 meters per second. That's I cross K. I plus K, sorry, I plus K. That's going to be crossed with the magnetic field B, which is 0.50 teslas in the K direction. Let's see, multiplying these two guys through gives us E, 0.707 times 0.5 times 10 to the minus 7 gives us 0.354 times 10 to the 7 meters times teslas over seconds. Then we've got I plus K crossed with K. Let's do that part next. We don't have to keep writing out terms. So this is equal to I cross K plus K cross K. K cross K is 0. I cross K is, you might just remember it, or you might like to look it up. I cross K goes the wrong way around the circle, so I cross K is equal to minus J. So then in our answer here, this gives us minus from this minus sign right here. We're going to multiply 1.6 times 10 to the minus 19 by 0.354 times 10 to the 7. That's going to give us 5.66 times 10 to the minus 11 newtons in the J direction. If you had a question about units, because here our units are coulombs times meters times teslas over seconds, that unit comes from the definition of a Tesla. When we pass a 1 coulomb charge through a magnetic field with a strength of 1 Tesla, and that charge is moving at a speed of 1 meter per second, it has a force of 1 Newton. So that comes from the definition of what 1 Tesla is. So there's our force on our proton that's moving up and to the right. Okay, let's move on to part B. Let's have our magnetic field to the right, same as it was before, but this time our speed is coming out of the page in the negative y direction. Let's do this one using right-hand rule, so magnitude and direction. So the magnitude of our magnetic field is the magnitude of the charge times the magnitude of the velocity times the magnitude of the magnetic field times the sine of the angle between those two things. So the magnitude of the charge is equal to E. The magnitude of the velocity is V is 1.0 times 10 to the 7 meters per second. Magnitude of the magnetic field, 0.50 Teslas. And the angle between V and B, well, one is along the Y, one is along the Z. That angle is 90 degrees. So we put our numbers in. And we get the strength of the magnetic force is 8.0 times 10 to the minus 11 newtons. We'll get our direction using the right-hand rule. We put our thumb in the direction of the velocity. Oh dear. Okay, I think I'm going to have to turn my page around here. Thumb goes with velocity, finger goes with B, and then... So the velocity is coming out of the page, that's towards you. Here we go. B is the magnetic field, that goes in the x direction, so I'll twist my page rather than twist my hand. So velocity is out of the page towards you, B is the magnetic field, goes towards this end of the page. Your extended middle finger goes towards the top of the page, so in this coordinate system that would be the z direction. So it points up, that's the z direction, or k hat. So we'll write down our force as a vector, because vectors always have to be written with their direction. 8.0 times 10 to the minus 11 newtons in the k direction. So there's our magnetic force. Another problem similar to this one you can try from the textbook is number 27 from chapter 29. That's really similar to this. The answer is in the back, so you can double check and see if you got it right.